In this video, we're going to have a look at the strength of an acid and see if there's any relationship between the strength of an acid and the concentration, or if indeed they are the same thing. From our previous work, we know that if we put hydrochloric acid into water, it ionizes to form hydronium ions and chloride ions. If we show this diagrammatically, we have our hydrogen chloride and our water, and those are our two reactants. The hydrogen is donated to the water, making an H3O plus ion and leaving us with a chloride ion, and these are the products of our reaction. So therefore the HCl was our proton donor and the water was our proton acceptor. But to what extent does this reaction actually occur? Does every hydrogen chloride molecule get converted into H3O plus, or is it only a few of them? This is what determines the strength of a particular acid. A strong acid is one which almost completely ionizes in the presence of water. So that means that our hydrochloric acid is converted almost completely to H3O plus and chloride ions. There will be very few hydrogen chloride molecules left, so in solution it'll be water, hydronium ion and chloride ion. Weak acids, on the other hand, ionise only to a very small extent. So if we take ethanoic acid as an example, less than 1% of it ionises to give us hydronium ions. So most of the molecules remain as ethanoic acid in solution, and there's only a very small amount of the hydronium ion and the ethanoate ion. We can actually write an equation to show what happens, showing the formation of the H3O plus ion, but very quickly that will reform to give us the ethanoic acid again. So we write a double-headed arrow that shows that the back reaction to give us the ethanoic acid occurs to a much larger extent than the forward reaction, which gives us the H3O plus. If we take a strong base, such as sodium oxide, and we put it into water, the first thing that happens is that it immediately dissociates to give us sodium ions and oxide ions. Those oxide ions then immediately react with water to form two hydroxide ions. The oxide is acting as a base and it's accepting a proton from the water to give us the two hydroxide ions. Now, because this is a strong base, this reaction happens to a very large extent in the water, and quite a large number of hydroxide ions are produced. So just to summarise, acids produce the hydronium ions when they go into water, and bases produce the hydroxide ion. The extent to which they produce these two ions determines on whether they are strong or weak. If there's a large production of ions, then they're strong. If there's only a small production, then they are weak. You remember that there are some acids which we call polyprotic acids, which are capable of donating more than one proton. An example of a diprotic acid is sulfuric acid, and a triprotic acid would be phosphoric acid. All of these acids can actually donate protons in a two-step procedure. Sulfuric acid first of all reacts with water to give us the hydrogen sulfate ion and a hydronium ion. This reaction occurs almost to completion, so this reaction, the H2SO4 is acting as a strong acid. However, it's also possible for the HSO4 minus ion to act as an acid as well. However, that second reaction doesn't go to a very large extent, and the sulfate ion and the hydronium ion that are produced in smaller quantities. So again, we use that double-headed arrow to show that that reaction does not occur nearly as much as the first reaction. Now we come to the difference between strength and concentration. Concentration is how much acid is dissolved in the water. That means how many moles of hydrochloric acid we put into the water to try and get it to dissolve. And the adjectives that we use to describe this are a dilute solution, a concentrated solution, and so on. I suppose your cutoff point is less than 1 molar solution we call a dilute solution. Anything above that is concentrated. Saturated is going to be when you can't dissolve any more in it, and that's going to depend a lot on the solubility of the substance, so we can't actually give you a number for that. But it suffices to say that dilute is less than 1 molar. On the other hand, the strength of the acid depends on how many ions you've got in solution, so how much that acid or base is going to break up to give you the hydroxide and hydronium ions. and the terms strong and weak apply to that. So it is possible to have a dilute strong acid and a concentrated weak acid. As far as which ones are going to be strong and weak, this is something that you're just going to have to memorize. The strong acids are things like hydrochloric and nitric acid, and the strong bases are sodium hydroxide and potassium hydroxide. The weak acids, on the other hand, ethanoic, and probably the only weak base we'll need to consider is ammonia. So as I said, concentration refers to how much of the acid is dissolved, and the strength of the acid is referring to how much will ionize. So have a look at these beakers containing solutions. We've got 2 concentrated solutions and 2 dilute solutions, but some are strong and some are weak. Have a look at the images that are there. In the first case with the ethanoic acid, we can see there are lots of ethanoic acid molecules there, but very few of them have ionized. So that means we've got a concentrated solution because there's lots of them there, but it's weak because we only have a few of the H3O plus ions in solution. There's little ionization. On the other hand, the second beaker shows us dilute ethanoic acid where there's only a few ethanoic acid molecules there and only a few of them have ionized, so it's weak and dilute. The next beaker shows us hydrochloric acid where we have a lot of hydrochloric acid molecules, but because it's such a strong acid, most of them will ionize in solution and exist as chloride ions and H3O plus ions in solution. And the last beaker shows us a very similar thing, but in this case there's not much hydrochloric acid that's been added to the water, so we don't have very many ions in solution. So it's a dilute solution, but it's still strong because all the molecules of hydrochloric acid have ionized to give us our H3O plus ions and chloride ions. So let's try a couple of examples and see if we can identify whether they're strong, weak, concentrated or dilute. Take 10 molar hydrochloric acid. So first you have to think, is hydrochloric acid a strong acid or a weak acid? Well, in general terms, it's a strong acid. Now look at the concentration. Is that going to be greater than 1 molar? Yes, it is. So therefore we have a concentrated strong acid. What about ammonia? Ammonia we know is a weak base, and the concentration there of 0.02 is less than 1 molar. So therefore we're going to have a weak dilute ammonia solution. What about this one? Hydrochloric acid. Again, it's a strong acid, but we don't have very much of it present, so it's going to be a dilute strong acid. Ethanoic acid is generally speaking a weak acid, but look at the concentration. The concentration is 5 molar, so it's fairly strong. It's a concentrated weak acid. Sodium hydroxide is a strong base, but the concentration is less than 1 molar, so it's a dilute strong base. Sulfuric acid, remembering in this case it can donate 2 protons, generally speaking a very strong acid, but the concentration is less than 1 molar, so it's going to be a dilute strong acid. So summarising what you need to know for this part of the unit is we still need to know the difference between an acid and a base, an acid being a proton donor and a base is a proton acceptor. We need to know the difference between a strong acid or a weak acid as being the degree of ionization that occurs when you put them into solution. And you should be able to give a couple of examples of each of a strong acid and a strong base and so on. Polyprotic acids, you remember, are acids which are capable of donating more than 1 proton, and you should remember that the second reaction doesn't occur to the same extent as the first reaction. And you should also know the difference between strength and concentration, remembering that concentration tells us how much is dissolved and strength tells us how much ionization has actually occurred in the solution.